Alrighty, today we're taking a look at question 2 for recitation 23. And for this one, we're trying to find the point on the x-axis where the magnetic field is going to be 0, right? So we have a magnetic field caused by this wire, which I didn't copy the larger picture, and this wire, right? And they're both coming up out of the page, right? So we're given that they're a distance d apart, and we're given that d is our 20 centimeters, or 0.2 meters. Again, everything always in base units. Right? And now if we look at, we are given the current through each of the wires. We will start with that later. Right? If we look at our right-hand rule for this one, it's hard for me to kind of do it, but here's the thumb coming up out of the page. And your fingers are going to curl around kind of like this, right? I'm not good at drawing hands, all right? So they're going to be curling around counterclockwise, right? Up around this way, right? And the same thing, since it's also coming up out of the page, it's going to be curling around counterclockwise, like that, right? So if we're looking at our I1 over here and our I2 over here, right, on this side to the right of it, it's going to be going up, and the left side is going to be going down, and the same thing for I2. It's going to be going up and down, and that's just the direction of them. Oop, why did I put another arrow on that side? Right, that's just continuing that arrow around, right, because it's going down in the middle and up on the outside, up in the middle, down on the outside. Just forgot how arrows worked for a second. And so what's going to happen is, right, if we're off to the left of both of our wires, our magnetic field from this wire is going to be pointing down, and our magnetic field from this wire is also going to be pointing down. And then same thing over here, they're both going to be pointing up. So the only way they can cancel out to 0 is if we were in between the two wires with one pointing up and one pointing down when they're of equal magnitude, right? Our fields have to be of equal magnitude. All right, well, we know, and we're given in the problem, that their currents are different, therefore they're going to have different radii, right? So one's going up, one's going down, we're going to set them equal, right? So that's our equation for B, right? Our mu naught times current over 2 pi r, and that's going to be like for I1 and R1, I2 and R2, respectively, right? So our mu naught I1 over 2 pi R1, right, our distance from the distance from our first wire, has to equal mu naught I2 over 2 pi R2, right? And we're given in the problem that our I2 is 3 times I1, right? So I'm just going to simplify this real quick, right? Divide both sides by mu naught, multiply both sides by 2 pi, and we get I1 over R1 equals, and then I2, we were just told, is equal to 3I1 over R2, right? And we can divide both sides by I1 and get rid of that as well. To really simplify things, 1 over R1 equals 3 over R2. Yeah. All right, so we know that if we're setting our 0 over here, like it kind of looks like in the picture, our x-axis is going off to the right. I can move this arrow slightly. Yeah, you can see our x-axis is going off to the right there. So we're going to set our 0 at I1. Our 0 is going to be over here. That means that 0.2 is over there. And at some point in the middle, it's marked with an X. Stop selecting the picture. It's marked with an X, but we know that some just arbitrary point in the middle, that's going to be what we're looking for, right? The distance over here is R1. The distance over here is R2, right? Because that's our distance from each of our things. So right now we can see that our R1 plus R2 has to equal 0.2, right? So if we're setting our 0 off to the side over here, our position on the x-axis is just going to be given by whatever R1 is. So I'm going to solve this equation for R2 in terms of R1 and then plug in over here. All right, so if I'm solving for R2, it's going to be R2 equals 0.2 minus R1. We can plug this into our equation over here, that 1 over R1 equals 3 over 0.2 minus R1. And then we can cross multiply. So it's 0.2 minus R1 equals 3 times R1. Add R1 to both sides. 0.2 equals 4 times R1. And then you get your answer 0.05? 0.05? Yes, 0.05 meters. That's our R1. Again, since everything's in meters, look back up. Here's 0.05. Here's our 0.2. All this jazz. And then your final answer, you actually do want in centimeters, but base units always, and then convert at the end, right? So 0.05, that's just going to be 5 centimeters. Right. All right, well, I hope you found this at least a little bit helpful. Let me know if you have any more questions on this problem or any other problems you want me to try to explain, and I'll do my best to explain them because I guess Sydney explains stuff.